challenge their inner like coding master. So I really want to like say that it's a very good opportunity for you guys to experience solving a real world problem in a time frame. So specifically for programming, the theme is the theme for UTech is solving a problem according to a natural disaster. So the programming competition revolves around the same theme. It's going to be a problem statement on a natural disaster, and you'll have to solve it under 6 to 8 hours. And UTech is happening on January 18th to 19th, 2025, and the tickets are on sale right now. And I think you all should participate. It's a very good networking experience for you all as well. And I'm just going to hand it over to Tasfia now.
So yeah, it's as Zuha said, this is your chance to showcase your talent, learn something new, and network with industry professionals as well. Plus, the top teams will advance to the Ontario engineering competitions or even Canadian engineering competitions and get a chance to compete at the provincial and even national levels. As said, tickets are on sale already. In fact, you can get them right now by scanning the QR code above and signing up. You can register as a team or even as an individual, and we'll pair you with others. So don't wait, scan the QR code, and also check out our website at utech.school.ca or follow us on our Instagram page for more information about other categories as well. I hope to see you all on the 18th. Thank you.
Thank you. If you guys have any questions, you could also email us at the email on the website and on Instagram. Just text us and we'll answer any questions.
Okay, I'm going to make a suggestion here. I know you guys are supposed to have your teams formed by January 17th. The competition is January 18th and 19th. What a really good way to get started with your team and figure out how your team works. And with a programming challenge, I think that would be a really good way to start the term with your team. So just a suggestion here. Welcome to Lecture 2 in ECE297. We're going to talk, I'm going to finish up a little bit about making ideas memorable and teaming, and then we're going to move on to Git, which is going to be an important topic for you guys to get to. Now, we know a little bit about WDO. Hopefully you've had a chance to take a look at the assignment. I rushed through this part of the lecture last class, so I just want to emphasize a couple things in relation to Made to Stick. Okay, obviously it is a big read, or looks like it's a big read. It isn't a textbook, so it shouldn't be as many pages as it appears to be. But again, what I wanted to emphasize is those concepts, in abstract are very, very simple, right? They can be contained in that acronym. They don't seem like they're a lot more than common sense, but really it's important to look at the examples, right? And it comes down to even this definition of this idea of making your ideas simple to make them stick better, right? Because I think there's often a time when we think about the idea of simple as compact or short or easy. That's not what it means at all. It's quite contrary to that. It's compact, but it's also something that's very core and meaningful, right? Like a proverb, not something that's just a soundbite. And again, I think it's the examples in the book that really help flesh out the idea of how to make your ideas a little bit more sticky throughout. Okay, so as an example of that, I would kind of walk through what we attempted to do at the beginning of the first lecture. Maybe not super successfully, but we'll see. What we tried to do at the beginning of last lecture, when we had Professor Yassine up here speaking rather poorly at the beginning, was to kind of tap into two of those principles, right? Unexpectedness and concreteness, right? Now, remember, these principles are always going to be tied into the core message, right? Which was at the beginning of that lecture, the idea that communication matters. And we did a couple of things, right? We did, I hope, something a little bit surprising at the outset of lecture 1 to get your attention. And then we also showed you what the impact, showed you rather than told you an example of what poor communication looks like, right? And we did this both in a way that was linked to the core idea of this part of the lecture, communication matters, and also linking it to kind of research findings that communication is an actual field of research, right? And then we were able to kind of discuss its impact on your impression of our authority as speakers up here, okay? So there's an example of how we're taking two of those principles and trying to build that into the way that we deliver even this lecture. Okay, so let's talk briefly about where we expect you to apply made-to-stick principles. And we're expecting you to do it in a couple of ways. The first is going to be just use the strategies that are outlined in made-to-stick to make your communication more meaningful and significant to the speaker, to the listeners or the audience, okay? And the second part is to kind of use made-to-stick to analyze or to justify your own communication strategies, okay? Now, in this map of your deliverables, your communication deliverables, essentially you're gonna be doing these sorts of activities in a couple of areas, right? So in WD0, you will certainly very explicitly be using made-to-stick principles to analyze or justify communication strategies. In your graphics proposal, you'll mostly be doing the kind of employing strategies. Similarly in OP1, because there's not a long time for questions there. But in your OP2, we are gonna ask you about how you planned your presentation. So you're gonna be able to use those principles to justify what you did in that presentation as well. And in your communication instructor meetings, right, where they are serving as project managers essentially, you're going to be given the opportunity to talk about how you can apply these strategies to your upcoming deliverables, right? So a lot of options to use this here, okay? Now ultimately what we want you to do with Made to Stick is, well, we hope it sticks. Right? We think that in APS 111, 112, what you did was write a very highly specific genre within a very specific context of the design course, right? You were given a really clear set of rules you had to follow, but you don't get that in industry. Right? You're not going to get that going forward. Even in your upper level courses, you're not going to be given a template or a lot of detailed instructions or kind of the opportunity to discuss with communication instructors, right? And what we're hoping that you take is going to be principles from this book that we will also kind of translate to kind of more traditional rhetorical principles for engineering communication, and that you'll understand not just how to communicate effectively, but why to communicate in these ways or why to use these strategies, and that you'll be able to use your own engineering judgment to apply these principles to where you have to, because they don't always apply, okay? And that's something that's important to talk about later on, okay? So ultimately, the goal is going to be transfer, right? To learn and practice in 297, to internalize these principles, and then ultimately be able to apply them in the rest of your career, academic and in industry as well. Okay, so that's kind of the overview of Made to Stick. We'll be covering a little bit more about how to use Made to Stick to do WDO, and we'll do an example of an analysis in lecture 4. So be sure you're here for that. But that's kind of an overview of what we hope to accomplish by using Made to Stick this year. Okay. Now I'll talk very quickly about team formation. I know Professor Yassine already talked about this, but I think it's really important that we kind of cover this sort of idea, right? Because in APS 111, 112, one of the major complaints about that course is I don't get to pick my team, right? And you get stuck with whoever you get stuck with. Now, one of the major problems in ECE297 is that you do get to pick your teams, right? Logistically, it's challenging, and sometimes people make the wrong choice. Right? So I want you to be very careful and think about what principles or criteria that you're going to use for team formation, right? And there's a lot of things that you might kind of think about as as kind of a criterion for team formation. Like some of these are things like, oh, I want to find someone who's an awesome coder. I want to be with my friends. That can lead to some issues. I want to have someone with a similar personality. I want to have the same hobbies as they do. Maybe I want someone who likes gaming. I want someone who's fun, or I want someone who is going to kind of push to do really well, right? What I try not to be is in this stage where you're kind of like whomever I can get, and that's January 17th. If you haven't had your team selected by then, you'll be put in a team by me, and then we'll meet and talk about it. So certainly you'll be put into a team, but I think this is an opportunity for you to take an active role in choosing what your term experience is like. And I think a lot of people were frustrated by not being able to do that last year, right? And so, but if you're gonna do it this year, try to do it right. So try to get as much of this information as possible, okay? Now I want you to think about 3 things in particular, okay? And Professor Yassine mentioned some of these, but not all of them. I think that there's a real logistical aspect to team formation and how teams work, right? So you want to think about that. You want to think about having shared values and then complementarity, okay? So logistics are things like, where are you guys going to work? When will you work? Do you work in the same times, or are you drastically different people? How often do you plan to communicate? Whether you're kind of typically someone who's on time or someone who's always struggling to get things in on time. And if you can find agreement here, this would be a good thing. Like if you work at the same times, it's more useful than kind of like working at different points and times, right? Shared values are things like, what are your expectations of your group member and yourselves? What level of achievement do you want to get at? And what's most important to you when you're dealing with others, right? Is it someone who's responsible? Is it someone who communicates well? Is it someone who is beyond anything just competent? Is it accountability? What are the things that are really important to you? And these are things that you're going to explore in your first CI meeting, right? Just to make sure your teams are on the same page. But it's something that you should think about as you're selecting teams as well, okay? And then finally, there's this issue of complementarity, right, which Professor Yassine talked about. Do you have coverage for the key skills and characteristics that are needed for success? Right, so coding versus communication, debugging versus design thinking, for example. Are you a creative thinker, or are you a very methodical thinker? Maybe you want a couple of different types of people on the team. And are you a conceptual thinker versus a detailed level thinker, right? These skill sets and kind of orientations have different purposes and functions within your ECE297 team, and you might want to satisfy both of them, okay? So those principles and your kind of like choices that I laid out before are not really mutually exclusive. It's not necessarily a bad criterion to try to find someone with similar hobbies so that you can have a good relationship. But those are things that you should you should try to balance, right? Things that are important to good team formation, and also things that might just keep you happier as a team member in ECE297, okay? And my last word on this, in terms of team formation, is that there's research here too, right? So like technical communication, there are fields and journals that are devoted to teamwork and team study. So Journal of Management, Team Performance Management, these are academic journals where people do research on that sort of thing, okay? Famously, Google conducted a study on team formation a few years back, right? It was called Project Aristotle. And does anybody know anything about this study and what its findings were? No? It was a pretty important study. They did find a lot of things, okay? But the most important thing they found about successful teams might be a little surprising. It's not how competent you were technically. It's not necessarily about communication. It was really about being able to find within your team some psychological safety. What does psychological safety mean? Well, it means like the ability to say what you think, not worry about how others think about you within the group, and having this psychologically safe space was really key to team performance at Google and in the study, okay? So as you're thinking about your team, really do consider how you can build a psychologically safe space, okay? Now, there are a lot of findings. There are more findings. I'd say there are 4 or 5 key findings in this study that I may talk about a bit later, okay? But I wanted to kind of put this one out there initially, okay? And then the last thing I want to say about teams is that there is a guidebook that has been published by iLead, which I hope you're familiar with here, right? The Leadership Institute in engineering, that is about effective hybrid teaming. Now, you're kind of in person, but you will be doing some of your work remotely, and you might want to check that out if you are interested, okay? And you'll have lots of opportunities to discuss your team performance with your project manager and CI. Okay, so hopefully I'll see all your teams by January 17th. If not, I'll be in touch with you. Thanks.
Thank you, Professor Chong. Can you all hear me? Okay, perfect. So just let me switch to my screen. There you go. Okay, so good morning, everyone. I hope you've had a good week so far. I'm just going to start giving my 2 cents on the UTech competition. I'm not a sponsor for the competition, but remember what we talked about in the first lecture is that the best thing to get better at software development, you have to practice. And these are the best opportunities to actually practice your software skills. They actually introduce you to how to use software development on real-world applications, and they can also improve your skills to prepare for interviews later in your career. Like they will probably definitely ask you questions like how to code a problem in a timely manner. I personally did a lot of software competitions in my undergrad, and they helped me a lot when I applied to grad school or applied to jobs. Okay, so today I'm going to talk about the technical side of working in a team and how to coordinate with other software developers, how to share your code. This is called version control. It's one of the most important technologies when it comes to software development. It's definitely used in every single hardware or a software company in the industry, so you will definitely get exposed to it in one way or another. Specifically, we're going to talk about Git, which is one of the most popular tools to do version control. It's widely used, it has a wide community. It's used in open source projects, it's used in different companies. We use it, for example, at Cerebras. So, yeah, but first, let me introduce you to why we need version control. We don't want to learn something that we might not need. So, let's say we have this project. It has 2 CPP files. It has 2 header files. And let's say we've hired Tony Stark to, he got bored from Marvel, so we hired him to do our project. And he is working on this right now alone. So a typical development cycle would be edit some files, then save your changes, try to compile your code, and test it. Okay? So hopefully everything works, but unfortunately nothing works from the first time, and there is definitely going to be some problems. So let's say that Tony here was doing some work, and he found that, okay, the program broke. Okay? So let's say he only made one change and the program and discovered that the program broke. Okay, that's easy. We know what he knows what he changed, so he can undo these changes and go back to where he was, or to the working version of the project. But let's say that he did several changes in simultaneously, and then he discovered that something broke, okay? And he forgot what he did, for example, let's say for the last 3-4 days. So how can we figure out what changed to go back to a working version of the problem? So the first problem we have is that we need a way to go back to a previous version, a working state version of the program, okay? So I'm gonna give you a little bit of time here to basically talk with your colleagues and discuss between yourselves to give me some suggestions on how to tackle this problem. Don't tell me Git. We know that Git is the solution. We're gonna go for it, but let's start with some simple solutions first, okay? So let me here put a timer. Okay. Is the timer showing? No. Yeah. Okay, time is up. So let's hear some suggestions. Click on the, yeah, so we have one here, D12, where are you? Yeah, so let's see. Yeah, you gotta speak in the microphone. Go ahead. D12, oh, was that on purpose or no?
No, that was by mistake.
Okay, no problem. Anybody else? Nobody? Yes, D10. Let's put you on the microphone. Go ahead.
Like you can just like copy and paste it into like a document or
Sorry, you gotta speak louder.
you can just copy and like, it might be stupid, but you can copy and paste it into like another document or like another code file and then just go back to it if you need to.
Okay, yeah, that's a good suggestion. So basically, your colleague here is saying that we can save copies of our project from time to time and try to go back to that copy if we found that there is an issue. I'm gonna put you on the spot and ask you, do you see any problems with that issue? With that suggestion, sorry.
Like a problem would be if like you have to copy over and over and over again, what if you forget to copy it? Like then what? Then you just lost all your
Right, so how often should we copy this code? Do we copy it once a week? What if we did a lot of changes during this week and now we lost all of our changes that we did, or like we forgot what we did in this week? What if we do it like every 5 minutes? Let's see. So, is that gone? Yep. Okay, so yeah, as your classmate said, basically make a copy of the file, of all the files really often. And this basically, this way we can switch to a backup copy where we know that it was working when we do something wrong. Okay? But one of the problems is, well, as we said, how often will we copy this? Every 5 minutes? This might get big. If we do it like every minute or every 5 minutes, the size of the project is going to bloat, and basically we probably won't have enough storage to store all our files. Okay? What if we have like thousands of backups right now, and we don't know which copy we should go back to? We don't have any tracker in that sense. So, okay, this was the working version, the last working version of our code. Okay? What if we forget or to actually back up our code? And then we discovered that, okay, there is something not working, but we don't know where the problem is. Okay, so that's the first problem. Basically, we need a way to go back efficiently to a working version of the problem. Okay, let's talk about the second problem. Now, most software projects are going to be done in teams. And in in this project, for the sake of explanation, we've decided to do a crossover between Marvel and DC and get help from Bruce Wayne, because we know that they are both tech savvy and they can implement the test that we need. Okay, so let's say Tony Stark is basically editing some file, and Bruce came and edited the same file at the same time. So both saved their changes. Now they tested, but because Bruce saved later, basically all his changes are saved, and Tony lost his changes. So he basically got mad at Bruce because he overwrote his changes and lost what he did for the past, let's say, 2-3 days. Okay? So the second problem is we need a way to prevent the conflicting edits on the same file. So let's do this again. I'm gonna give you another 1 minute, and whoops. Yeah, to discuss and give me suggestions on how to tackle this problem. Basically, we need a simple solution, don't tell me get again, to try and prevent conflicting edits on the same file by different team members.
Any simple solution. Just don't work on it. Work on it on Google Docs and then test it on Windows. It's a family group chat.
Okay, time is up. So yeah, let's hear suggestions. Who got any solution to this problem? Anyone? No one? Yes, sorry. Do you have a solution? There you go. You can speak.
Okay. Well, what if the solution is to make a copy with your name on it?
Make a copy with your name on it. Okay, basically each one is working on his own copy.
Yes.
Okay, that's a good suggestion. That's moving towards basically what version control is.
Right.
Okay, but any other suggestion? Yes, go ahead, A9.
Server.
Sorry?
Use a live server.
Use a live server. What do you mean by that?
Like on VS Code, you can host a live server and you can edit with other people at the same time.
Okay, something like, let's say, Google Doc, basically. Okay, it's something online. Everyone can access it at the same time. They can both do their changes, and often they won't lose their changes, right? Okay, that's a good suggestion. Do you see any issues with that problem, though?
Like you have to be online at the same time.
Other than that, basically, what if the team got so big? Do you see a problem where the code can basically, like they will add conflicting code and things might not work, right? Okay, these are all good suggestions. Basically, the first thing that actually comes to mind is I'm gonna coordinate with my teammates. I'm gonna tell them, don't work on this thing because I'm working on it. So I'm gonna own, like, let's say file1.cpp, and then Bruce Wayne will own file2.cpp. Okay? So, but what are the problems with that? What if I forgot to read my email and my teammate emailed me about something that I shouldn't edit this, and I went and actually edited the problem? What if we both sent emails about file1.cpp at the same time? Again, this is a problem that might occur because we cannot control who is sending what, right? What if the team got bigger? Like, what if we had all of the Avengers doing this project, okay? This probably not gonna scale to with too many people. We cannot coordinate this email communication back and forth among large team members group. As your friend suggested, we could use something like Google Docs. But the problem with this is, it is a bit better than using emails, But again, it might get slow if a lot of people are editing at the same time, or we can lose these small edits that nobody found. Okay, moving on to the third problem, which is, I think, the most important one, and I don't think there is a simple solution for this. Okay, so let's say Tony is editing file1.cpp, and Bruce Wayne is editing a different file. So now they don't have conflicting edits on the same file, but they basically working on different files. Again, a typical development cycle is I'm gonna do my changes, I'm gonna save it, do build, let's build the program, try to execute and run some tests, and something is not working. Why? Let's say that Bruce hasn't saved his changes yet, or he's still like half complete with his tasks, and Tony tried to run his changes, but because of Bruce's half complete changes, basically the program broke. Okay, so the third problem is basically we need a way to control when to make our changes visible to other teammates or other developers. Okay, so let's recap on what the three problems we have are. One is we need a way to go back to a previous working copy of our project. Two, we need a way to prevent conflicting edits to the same file, or like so that we don't lose our changes. And three, we need a way to control our changes to become to control when our changes become visible to our team members. So basically, we need to wait until we test everything. We see that our changes are working fine. Now we can basically expose them to our team members. And the solution for this is what we call a version control system. Our choice here in this course is Git. There are several version control systems, but the Git is the most popular one, and that's why we are basically teaching you. Okay, so let's look at what a version control system is. Basically, one of your team members said that, a teammate said that one of the solutions to, for example, trying to prevent conflicts across team members is for each one to have their own working copy of the project, and that's what version control is. There are, let me find my laser pointer here. Okay, yeah. So Tony here has his own working copy. Bruce here has his own working copy, and in the middle, it can be hosted somewhere. Basically, there is this big repository that hosts the main copy of the project. Okay, this is basically the main way of communication across team members. When we finish our changes, what we call it push. We push our changes to that main repository, and then the other team members can do some commands to basically fetch those changes. Okay, so let's see how does this solve problem 3, which is controlling when my changes become visible to others and their changes become visible to me. Okay, so let's go back to this slide, and let's say Tony has this own working copy and he's editing this file in red, and Bruce is editing another file in green on his own working copy. Tony saved, built a program, and tried to test it. Everything is working fine. Okay, and same thing, Bruce did that. Okay, now we are confident that our changes are working, and we want to basically expose them to our team members. So how do we do that? We do that through two commands from Git. One is called git commit, and the other is called git push. Git commit, what it basically does is that it tells Git that, okay, these are the changes that I've made, and I'm ready to push them to the remote repository. We haven't pushed them yet. We're just telling Git that store these as changes that I'm gonna push. Then we type git push, and that's what sends it to the remote repository that is shared across team members. Okay. So once we hit git push, the Git repository and the main Git repository will have the changes in red. Same thing that Bruce will do, and we will have his changes as well. Okay. Now, both of the changes are on the main repository, but both Tony and Bruce haven't seen the changes from the other team member yet. So how do we do that? We do this through a command called git pull. What pull does is basically it fetches whatever is new on the remote repository. We call it remote or the main repository. You can call it whatever you want. It fetches it to our working copy, and basically it tries to merge it with our changes. So once we do git pull, basically Tony will see the green changes and Bruce will see the red changes. Now there is this, you can see here, there is this -r option. It's an optional argument to git pull, but it basically makes it easier to understand. We'll talk about it later in detail, but for now, you just need to know that it makes it easier for us to understand the history of the changes. Like when we try to read the history of different commits, with -r, it basically sorts them in a way that we know who did what. Again, it's optional, but I recommend using it because it makes things easier when you, especially when you work in big teams and you don't want to lose who did what. Okay. So now each team member has the copy from has copied the main project from the remote repository. What is the first thing that we should do now? Anyone knows? Yes, ECE297. Resolving conflicts. Let's say that we have no conflicts so far. Okay, actually, yeah, let's say we have no conflicts so far. We're going to go to that. But there is still one more important thing that we need to do first. Yes, sorry, ECE297, again.
Can you expand the code?
Yes, run the code. Basically, we need to make sure that we know that we've tested our changes on their own, on our own local copy, but now we've basically pulled the changes from the other team members. We need to make sure that the code is working, it's still working, and all the tests are passing. So the first thing we need to do basically is rebuild, make sure it's working. Now, if there are conflicts, probably it won't rebuild, and we're going to talk about how to resolve conflicts later. But let's say we built fine, everything is fine. Now we run the tests and we found that there were issues. These are called integration errors or integration bugs. And this is why we recommend every time you try to develop something new, the first thing you should do is pull the changes from the master repository. Even if there are no changes, just make sure that there are, you are up to date. Try to run the tests and see if it's still working. If it's still working, that's good. If it's not, then try to resolve those bugs first. Try to figure out what the issue was. It's probably some conflicting error that you did and your teammate did. If you are able to resolve these changes, do a git commit push again to basically give the working copy to the remote repository, and pull frequently as much as you can to make sure that you are still in a working state of the project. Okay, so that's how it solves problem 3, which is basically when to expose our changes to the other team members. But let's talk about problem 1 again. How does this solve problem 1, which is we need to go back to a previous working copy of our code? Okay, the simple solution was, remember, to basically save a copy each time we do something new. Now, the image that I showed you earlier about the master copy of the repository is actually not representative, because what Git does actually, and what Git is good at, it's actually smart in that it saves the history of all of our changes. Okay, each commit that we do has a series of hexadecimal characters that basically tells Git that this is a change by this team member. And the commit message basically tells it These were the changes. So every time we do a git commit and git push, basically there is a new hash that is added or a new version of the project that is added. Here I'm just showing them with R1, R2, but they are usually, again, a long series of hexadecimal characters. Okay? So let's say Tony edited this thread file, did a git commit and git push. Now the R2 version of the master copy basically has this red version. Then Bruce committed a green file. Then R3 will have both. It will have both the red and the green. Okay? So Git knows all of the history for the software, even if it basically, even if it's a big project that spanned like years, we know exactly what happened in each commit. Okay? Let's see. Okay, now let's say that Tony basically pulled the latest changes that has both his and Bruce's edits, and Bruce did the same. Okay. Remember, git pull -r basically updates your working copy to match what is exactly on the remote repository. But which version does it fetch? It basically fetches the tip of the master branch. Here we call it, here it's R3. Basically, this is the latest version that was committed and pushed to the main repository. So Git has a pointer called, actually it's called head, we'll talk about it later. And when we do a git pull, it basically fetches the latest head version. Okay, so now let's say we did a git pull and build, and we are trying to test, again, like we do always. And we found out that there are issues, okay? So we need to know which edits resulted in those integration errors. Now let's say that Tony is confident and that he knows that his changes didn't cause these issues, but he wants to blame Bruce on this. So we need to find an evidence that Bruce did that. Okay? Batman is still not convinced that his edits resulted in those errors, and he's basically telling Tony, give me an evidence. So one way to do that is to basically go back to a previous version of the project, okay? And Git has a way to do that is with this command, git checkout, okay? Git checkout, what it does is basically you give it the hexadecimal character hash of the version that you want to look at, and what it does is that it updates your working copy to be the exact same state of that commit, okay? So once he does git checkout R2, he will go, the head pointer of his working copy will move back to R2, and it will fetch that. And you notice here now there is no green file here because he went to a change that only had the red changes in it. Let's say he tested and built. Okay, R2 works. That means there is a problem with R3. And the only change between R2 and R3 was what? Basically, Bruce's changes, okay? So let's say that Tony figured out what the issue is in his changes, and he wanted to basically update those changes. Now, Git will not allow you to update your current working copy because you are still based on R2, and it will tell you that, like it's some, with some message, it will tell you that you are in a state of called detached head. A detached head means that basically we are not at the tip of the master on the remote repository, and we are somewhere in our history. So it's telling you that you should go back first to your master version, try to pull any changes if there are changes, and then do whatever you want. Okay? So how do we go back to the master version? Anyone have any suggestion? It's literally like what we did with R2. So suggestions? Yeah, go ahead. Yes, git checkout master or git checkout R3. So you just take the hash of R3 and try to check out that. Okay, and when we do that, basically our head on the local copy will move to the latest copy of the master repository. Okay, now we can do two things. Either fix the bug if we know where exactly it is, or let's say Tony didn't actually figure out what the issue is and he just wanted to update the master version to be working again. So he decided that I want to undo Bruce's changes. And Git provides a way to basically do that. This is called revert. And if we provide the hash to the revert command, basically what it does is that it will just undo all of the changes that were added right in that commit. So remember, R2 had only the red changes. R3 had the red changes. On top of them had the green changes. Okay, so the only difference between these two changes is the green changes. What revert R3 did is basically remove those changes, and we went back to only the red changes. Now, just be careful is that this is a totally new commit. It's not the same as R2. It has R2 plus R3, then minus R3 again. So when you look at the history of your chain of the commits, you will find 4 different commits, and the last one is just it contains the same changes as R2. Okay, so we do that. We build and test, and now it's working fine. So, tada! Basically, we have a new version, the master version that is working, and then we can tell basically Bruce, go fix your changes and push them later. Okay, let's stop here for a second. Any questions so far? Great, that means, for me, that means that everything is clear. So, okay, so we talked about git revert, we talked about git checkout. Let's talk about what we call git log. Git log, basically, what it does is allows you to look at the history of the changes. So it gives you a series of different commits, starting from the latest one and going backward in time, and it gives you the hash of that commit, the commit message, which basically describes what the changes were, and that's why actually we tell you in M0 to always make your commit messages meaningful, because if for some reason you are working in a very big team and you don't know, you probably won't know all your team members, and they want to see what happened in that commit, reading that message will help them basically decide, okay, or investigate what happened. Okay, so again, it shows you a list of all the files modified by every commit and the message for each commit. Whoops. Yeah, it's moving, sorry. Okay, now Bruce wants to investigate what he did in R3 in order to know where the issue is. Okay, let's say he worked on different stuff and then he forgot what he did. So he wants a way to basically figure out what changes he made. And there are 2 ways in Git to do that. One is called diff. Git diff basically shows you the changes between 2 different commits when you provide the 2 different hashes. So in here, basically we're doing git diff R2, R3. It will show you the changes between these 2 commits. I'm going to give you an example of how to read that output. The second command is git show R3. Git show R3 will show you the exact same output as git diff R2, R3, but it's just shorter and more concise. Okay, so here's an example of diff output. And basically here, what it's telling us in red, it will actually have different colors, basically, if your terminal supports it. And what it's showing here is that the changes that you made in R2, in R3, is that you edited this file, file2.cpp. You might have edited actually multiple files, so it will show you all these files one by one. Okay, and then if you look at this line, it's telling us that after line 192, we've made some differences or some changes in this method called superhero setup, okay? And then it will show you the actual changes. So anything that with a plus sign, that means you added that, or whoever wrote that commit added that change. And anything with a minus sign, basically something that was removed in that change, okay? So Bruce, in this case, basically added that he is the best superhero, whatever, in this change, and removed Iron Man. So git show R3, again, it will show you the exact same output. The good thing about git show is that if you just type git show without any commit, it will basically show you the changes that you've made in the last commit, or whoever made the last commit. There is another use of git diff. We're going to talk about it later, but in short, basically, it allows you to also see what changed in your local copy before committing those changes to the remote repository. So let's say that you've made some changes to file1.cpp. You type git diff. It will show you that you changed file1.cpp, and these are the changes, but you haven't committed them yet. So if you want them committed, go ahead and commit them. OK, so one of the problems that we talked about in the beginning is that if we have multiple copies of the project, we might end up bloating the size of the whole project, and we might not